Hello, I'm meteorologist Jeff Matthews, and welcome to the module entitled The Solar System. Here we're going to learn about where weather actually begins. It's not even on planet Earth. It all begins with our sun, or our star, at the center of our solar system. Our sun, by comparison to other ones in the universe, is actually relatively mediocre. It's average in size, it's average in light intensity, it's average in output. But it's the only star we have, and it drives all of our weather. The planets rotate around the sun. So let's talk about each planet and how it differs from each other and how it goes around the sun. The first planet in the sequence is Mercury. It's one of the smallest, and any atmosphere it might have had was long ago burned off by the hot rays of the sun. So it's basically just a big rock in space. The next planet is Venus. It's considered our sister planet because it is most similar to Earth. It is similar to Earth in size. It also has an atmosphere like Earth, but it differs because whereas we have limited carbon dioxide that is just enough to keep the heat in, but also allow it to radiate back out at night, Venus has out-of-control warming, so it's not habitable. It also has some pretty weird weather. Because of the dense atmosphere, precipitation that's really made of acid, so we couldn't be there, falls but then suspends from the clouds. Because the atmosphere is so dense, the precipitation is actually lighter than the cloud it's falling from, and so it suspends in the air. That makes Venus very interesting meteorologically. And then comes terra firma, your home and mine, planet Earth. It happens to be in the right distance from the sun to get plenty of heat and light to sustain life, but not so close to burn off our atmosphere and not so far away that we would freeze. Also, because of the temperature and our climate here on Earth, it allows for water, and water to come in all three forms, which we'll talk about in a later module. The fourth planet is Mars, the red planet. It has a thin atmosphere, so it's not really able to absorb enough heat and retain it to sustain life as we know it. Plus, it's too far from the sun that any water that could be found on Mars would be frozen. The fifth planet is Jupiter. It is a big gas bag. It's true. Most of it is made up of gas. It has a small rocky core the size of Mercury, roughly, but most of it is atmosphere. And it's best known for the big red spot. That's a big storm on Jupiter that's been going on for centuries. The sixth planet is the planet Saturn. Saturn is most known for its rings. And then the seventh is Uranus. It also has rings. Now, when we talk about the eighth planet, here's something I bet you didn't know that makes it extremely interesting. You're probably aware that the Earth rotates on its axis. Its axis is slightly turned. So when it rotates, it's turning at a slight angle from vertical. The planet Neptune rotates on its axis on its side. How about that? So it rotates like this. And that, of course, leads to all kinds of interesting differences for that planet as opposed to the others. And then we have Pluto, the smallest planet, one that's been controversial in terms of whether scientists want to include it as a planet at all, and it's the most recent planet that's been visited by NASA probes. If we look from the top down, there are numerous differences that make the planets in our solar system interesting. First of all, the year is determined by how fast the planet goes around the sun, how many days. So Mercury's year is much shorter than, say, Neptune's year, because Mercury is able to navigate that circle much faster. So Mercury, a year there, is much shorter than on Earth or any of the outer planets. On the outer planets, the year is much longer. Many years of our year make up, say, Neptune's year. Other differences include the fact that some are made of basically rock, some are big gas bags, some have rings, and did you know that many planets don't even go around the sun in a perfect circle? Some of them go around the sun in the shape of an egg. In fact, the Earth goes around in an elliptical orbit, not quite that of a circle. Let's take a look at the sun as compared to its size to the Earth. If we could shrink the sun down to the size of a bowling ball, the planets relative to that bowling ball would look like this. Jupiter, the biggest planet in our solar system, would actually be smaller than a ping pong ball. How about that? And the Earth, that arrow represents that dot, which is basically the size of a pencil point. So the Earth is very small as compared to the size of our Sun, which our Sun is very average when compared to suns or stars in other parts of the universe. Now it's time for your solar system quiz. Are you ready? Get your thinking hat on and your pens and paper out. Question number 1. The Earth is referred to as a planet. The Sun is not a planet. What is our Sun referred to as? Question 2. How many planets are there? We just went through them. And for bonus points, can you name them and their position as we go out through the solar system? Here's a thinking question now. And it's okay if you get it wrong. It makes you think. If the Earth were now located where Saturn is, much further out, would we have people and plants and liquid water on Earth if it was in that position? Think about it. We'll take a moment and come back with the answers. Okay, question number 1. The Earth is a planet. What is our Sun? It is a star. Question 2. How many planets are there? There are 9. And can you name them? The first one's Mercury, then Venus, then Earth, then Mars. That's a leading hint for you. If the Earth were where Saturn is, would there be people and plants and water? In fact, there would not. It would be too cold for people or animals or plants to exist, too far from the sun for plants to photosynthesize, and if there were water, it would be in the form of ice. Far too cold to be gas or liquid. So that's your solar system module. Now we'll leave you with a little demonstration. Hello, and welcome to your demonstration portion of the solar system. Okay, it all begins with the Sun, which is at the center, and it spins in place. The Sun and all the planets move throughout the galaxy, but the Sun is at the center of our solar system. You ever wonder what causes the day and night, or the seasons, or the year? We're going to explain that. The Earth faces the Sun half the time and doesn't face the Sun the other half. If I were to color code it like this ball, the side that doesn't face the Sun would be in darkness. The side that does face the Sun would be in light. If the Earth went around the Sun without rotating, then half the Earth would always be facing the Sun and half would always be away. That would mean the side facing the Sun would always be getting hotter and hotter every day, and the side facing away would never get any light or heat, and so would get colder and colder every day. But because the Earth spins on its axis, then that means it's always turning, so a different face of the Earth is facing the Sun as it rotates, so all of the Earth gets light and heat from the Sun. That creates day and night, because the side that's facing the Sun would be called day. The side that faces away as it's spinning would be called night. So that's how you get 24 hours of day and night. How do you get the seasons? Well, the Earth sits on an axis. The axis is not straight up and down. For us, it's slightly tilted, about 23 degrees. That's important because as the Earth rotates, meaning spinning, and moves around the Sun, at different points, the top half is facing the Sun more than the bottom half. So in the northern hemisphere here, we're experiencing spring and summer, whereas the southern hemisphere, like South America or Australia, is receiving fall and winter. As the Earth spins and goes around the Sun and gets to the opposite point, now the top half of the Earth is pointing away from the Sun. And so we're experiencing fall and winter, but now Australia and South America in the southern hemisphere are receiving spring and summer. So that explains the seasons. How about the year? The year is determined by how long it takes for the planet to go all the way around the Sun one time. And for us, it takes just over 365 days. So there you go. The day is created by the Earth spinning. so that different parts of the Earth are always facing and then moving away from the sun. The season is because of the tilt. So the top half or the bottom half is closer to the sun at certain points of its orbit. And the year is when the planet makes an entire revolution around the sun and returns to its original point. That would be defined as 1 year. Let's talk a little bit about the moon, our only satellite. The moon also spins. It also rotates around the Earth and makes an orbit. In addition, the moon, based on how close it is to the Earth, because it doesn't have a perfectly circular orbit, when it gets closer to the Earth, it pulls the tides of water towards it a little bit to create high tides. And when it gets on the opposite side, then this side gets low tide. In addition, we have eclipses. A lunar eclipse on the Earth happens when the Earth blocks the light from the sun to the moon. So you can't see the moon, or it's very, very dim, for a few minutes or hours. A solar eclipse happens when they switch positions, and now the moon is over here in just the right place to block the sunlight from reaching the Earth. And so for people behind the moon, between the moon and the sun, they can't see the sun for a few minutes or hours, and it becomes a solar eclipse. There you go, your demonstration on the day, the seasons, the year, and how eclipses happen. I hope you've enjoyed this demonstration.